Project code ITPW12 project title non-isolated high-gain triple port DC to DC buck boost converter with positive output voltage for PV application. And for the PV application, we have to use the boost converter for getting the high voltage to satisfy the load. The boost converter have to classify into two types. One is isolated and other is non-isolated. In conventional, the non-isolated is only used. The isolated having the coupled inductor in between input and output. And for multi-port application, isolated converter is widely used, like the resonant converter, which is isolated converter, and which is mainly used for the multi-port application. But in this system, when using the non-isolated within the non-isolated converter, we have to use the multi-port application, like a three-port. Existing concept is only the two-port application because then we have to using the normal boost converter, which you have only one input port and output port. In case we have to use the buck boost converter or bidirectional converter also, input giving is a in a inductor side means the output have to boost that output we had, and in this side we have to give the input means, and this side either side we have to get the output as a buck. So this also having the two port. So in the conventional system, non-isolated system having only two port. Existing have the drawback. In case we have to use it for the this is implemented in isolated system. Means isolated system having the more advantage, but it having a coupled inductor, which will increasing the magnetizing current, and the switched components required for this isolated converter is high, and so complex it have the complex system. It became a complex system, and the output gain also less. But the proposed concept three-port DC to DC buck boost converter. This is a converter which is a single. It is single stage up because in some other converter like resonant converter having a two stage like input stage and in between coupled inductor and the output stage, but it requires a more number of components. But our proposed converter is single converter with having one input and two output. Within the converter, when giving the DC input from the solar PV, within the two output, buck output and boost output from the other port. And by using the converter, the high gain we have to get. We consider this is a first port, second port, third port, 1 2 3, which is unidirectional, and one having the 1 2 3, 1 to 2 is a unidirectional, 1 to 3 is a bidirectional. So this converter having the both unidirectional and bidirectional, having high output gain, and the other is when using the non-isolated converter with the multi-port, non-isolated, so it became the system compact. The black diagram solar PV is given to our proposed converter, and the boosted output is given to the load, and the bugged output is given to the battery. Application battery storage application, renewable application, and which is also used for the DC microgrid application, hybrid power generation like battery panel, supercapacitor. This type of hybrid power application also this converter is used. This proposed concept is implemented in MATLAB 2015 version, and PIC microcontroller is used in a prototype for giving the pulse for the proposed converter, and so you have to give the program by using the microprocessor lab. The minimum hardware requirement is MOSFET, transformer to excite the PIC microcontroller, and solar panel, 12 volt inverse panel, and other active and passive components are used. Thank you.